Alright everybody, welcome back to another Ask a Dev Unreal Engine tutorial. We are in our control rig series, and today we are going to be talking about what is commonly referred to as the reverse foot. My name's Kevin and I am going to be your guide through this little adventure. And one of the reasons that we're setting this up and we're going to go over this is it's part of the broader goal of giving you all the little bits and pieces that you need in order to create a nice, clean, simple rig that you can animate with. So with that, the reverse foot is something that's probably best illustrated through example. So let's hop into Unreal and take a quick look. All right, so here we are in Unreal Engine. And what we have is we're working from, this is what we're going to be building today. And we're working from the rig that we've been setting up so far, where we have IK legs. But in this particular case, we have one foot that is set up as a reverse foot. And we have one foot to illustrate the problem of why we need it. So let's start with what we have. If we take our foot and we move it around, if we want to rotate and roll our leg off of the foot, what we need to do is we need to, let's say we pose our leg, and actually I'm going to bring down my body just a little bit to give me some bend in the knees to work with. All right, so if I want to pose this leg so that it looks like I'm pushing off my toe, what I'm going to have to do is I'm going to have to rotate this in place. And then I'm going to have to grab this ball control, and then I'm going to have to rotate it, and then I'm going to have to counter that a little bit to finally get a pose that is more intuitive into the way the physics of an actual foot works, right? You don't think about positioning your ankle and then putting the weight on the ball of your foot. Your foot is already on the ground. The body mechanics of it works where the weight is already there and you just basically rotate up onto the ball of your foot and then eventually off your toe, depending on whether you're doing a run or a walk. So posing this right leg is the reason why we want a solution to make this more intuitive. So let me show you how much easier this is with the reverse foot. So here's what we're going to do. We are going to pick our reverse foot ball control. We're going to turn on a rotate, and now we're going to pivot up onto the ball of our foot. And we're going to do the same thing with the toe when we want to roll off our toe. So it's that simple. If we want to, we can do the same thing with the heel. So what we're going to do is we're going to take our heel control and we want to rock back onto the heel. So this is particularly useful for animators when we want to do something like passing positions. Actually, it turns out we can actually animate that as well. Let's move this forward a little bit, grab our reverse heel, rotate this back, and this is particularly good in order to be able to create some of these in animation what are commonly referred to as the contact positions, as well as the passing positions and the taking the weight position where we're actually rolling up onto the ball of our foot. So this is what we're building today, and we're going to do it using and starting from our basic IK setup. So rather than rebuilding everything every time to save time, we want to focus completely on the reverse foot, and that's what we're going to do today. So let's talk a little bit about how a reverse foot works. Okay, so what I've done here is I've popped open Maya to help us visualize exactly what we're building, because what we need to do is we need to build a new hierarchy. And this is why this is called the reverse foot. So let's hide our character skin here. And what we've got is we've got our basic Manny skeleton with an IK handle in it. And what we want to do is we want to be able to control the current foot by using an alternate hierarchy. And what does that alternate hierarchy look like? Well, this hierarchy, if you look at it, let's just delete our IK handle here. This hierarchy looks like where we have an upper leg, a knee, and a foot. And then in our foot, we have the foot, the ball, and then there's an implied toe and an implied heel here. Oftentimes you don't see these joints because they're frequently left out in order to save bone count, especially from the older days. But the general idea is there would be a toe and a heel here. And what we want to do is we want to create, and the problem is if we rotate this joint, what happens is the ball moves with it. Makes sense. That's the way forward kinematics work. The reason that we want to make a reverse foot that starts at the heel, then goes to the toe, then goes to the ball, then goes to the ankle is the difference in the order of rotation. So by having this heel here, if I rotate the reverse ball, look at what happens. As I rotate this, the heel is going to, or the ankle is going to get lifted up by wherever I put the ball. And if the ball follows here, then it's going to automatically counter animate. So what we are going to be doing right now is we are going to be building this hierarchy that goes from heel to toe to ball to ankle. That's why it's called the reverse foot, because it basically is the reverse of the traditional hierarchy. So let's get rid of Maya and give this a shot. That way you at least know what controls I'm building and why. So we're going to be working with the left foot. I am going to go ahead and I am going to add on, let's start with 3 controls. All right, so we need new control. I am going to call this new control the left heel. Remember, we're going to go heel, and then we're going to go, I'm going to call these reverse so that it's clear which ones are which. And let me go ahead and update my size of my fonts so you all can see this a little bit better. There we go. All right, so here we are. We've got our left heel. This is going to be our reverse heel. I'm going to duplicate that. I'm going to call this one our ball reverse. And then I need our actually we need our toe. It doesn't, the order doesn't matter yet because I haven't started parent things. So we need our toe reverse. And then we are going to need a placeholder for the heel, but I'm going to get for the foot, which I'm going to get to in a second. So remember, the reverse order is heel to toe. So I'm going to parent my toe to my heel to ball, and then finally we're going to go to foot. So we have 2 options. We could use the foot as a control, or we could use it as a null. I think I am going to create it as a null. So let's create a new null here. And this is going to be my left heel. Actually, we're going to call this the left foot reverse, so we know which one is which. All right, so now that we have our hierarchy, none of it is in place. We need to line everything up. So one of the things I want to make sure of is I want to make sure that we don't have any initial settings in our transforms, because it's going to be important that these all settle. Now, what we need to do is to position these. We want to go ahead and place them in our construction script. So let's take our heel and talk about our first problem. If we want to set the position of this heel control, how are we going to choose where that is? Well, what we're going to do, because remember, we don't actually have, and I accidentally have one in here, we don't actually have in our hierarchy, if you look at our joints, we have our foot and we have our ball. We don't actually have a toe position or a heel position. So much like we did with pole vectors, what I'm going to do is I'm going to go ahead and I'm going to add in a heel ref. So to do that, let's just go ahead and create a new null that we're going to put off of. In the case of the heel, we're going to parent this to the foot. So let's create a new null. I'm going to call this the heel ref. And then off the ball, I'm going to create a new null. I'm going to call this the toe ref. Now, we could do this with just using transforms and placement, but I like to see it visually, and I think it will be easier for you all to see if we do this visually as well. So we're going to call this the toe ref. Now all we need to do is we need to place these. My heel, interestingly enough, is it's actually magically in place, and that is because I had actually done this prior. So let's just get rid of it so you can see what it is. Let's delete that. So our heel is currently zeroed out, and so is our ball ref. So what we need to do is let's take our heel ref and let's get it to be approximately where we want the heel pivot point to be. This is the pivot point. So if we move this down in X, you'll see that it's kind of moving into place, and we'll move it back. And let's just say that that is a relatively good pivot point for the heel. Maybe a little bit a little bit further forward. Let's call this 5. We'll go -10. We're going to go to even -10. Ooh, and I believe this should be -5. Yeah, we're going to go an even -10 and -5. That's going to be our heel position. And so what we need to do is in our construction script, I'm just going to set that as well. So let's just take our heel ref and we will set it. And we're going to set the initial, and the value we said in translation was going to be -10, -5, and 0. Let's connect this in. And we need to make sure that our actual heel ref doesn't have any initial on it. Let's get all of this reset. Okay, compile that. All right, so it looks like our positioning is slightly off, and I think we need to go down a little bit more. So let's go down to, oh, that's because we're doing this in global space. Let's switch this to local space. Okay, so local space is better. All right, so now our heel reference is in position. We need to do the same thing with our toe reference. So let's figure out what that should be. I'm just going to come over here, and it's a little bit down, that's fine, but it's mostly going to be forward. And once again, what we're doing here, sorry, the viewport is so sensitive. We're kind of just putting this at a point that makes sense for our toe to pivot off the ground when we go for that contact position as an animator. So I think that looks pretty good. Let's call this 8 and it looks like maybe 1. We'll call it 8 and 1. So we're going to do the same thing. We're going to set the initial null. And in this case, we're going to be setting the toe ref. So under item, let's change this to toe ref. Okay, let's compile that. Now we also need to make sure our toe ref, if we just zero all of this out, I accidentally unclicked toe ref. Transform, current, let's just reset all this, compile. Okay, now let's double check. In our local space, because this is, remember we had said that this would be 7. We copied this should be 7, and we had said that this would be 1. All right, make sure everything else is 0. All right, so what we've given ourselves now is we've given ourselves a position as a reference point to use for the heel and the toe. That's all this did. We could have just set it manually, but it's it's easier to visualize. Now that we have those, what we can do is we can start actually placing our controls. So where does our heel control go? Well, let's set the control position, and we're going to set it based on our heel reference. So let's go get, let me collapse this down and make this a little bit easier to find. So let's get our heel reference. We'll get this null, and we're going to feed this into our transform value for our heel, our reverse heel, and we're going to make sure it's in global space. And let's go ahead and compile, and you'll see that that pops right down there, which is great. Now, here's the thing that I want to do. I'm going to make this control a little bit smaller, so it's a little bit easier to visualize. Okay, and I'm also going to change the color slightly so that we can see that. Okay, so that's going to be the heel. Now we need to move the toe into place. So let's set our toe control position, and that is going to go where our toe reference is. And our toe reference we have as this null here, so let's get that. And we'll feed this in. Want to make sure we check initial again. And our toe should move up to the toe point, which is great. And I'm going to make the same change to our toe. Actually, let's just go ahead and do all of these right now. We will change all of these to this little kind of a lighter red, and we'll change our scale down so they're all a little bit more the same size, and it's clear which ones are the reverse controls and which one is the forward controls, for example. Okay, so we now have our toe in position. Now let's go ahead and set our ball position. And our ball position, as you would expect, is going to go where the ball is. So we're going to set the control to the ball. Let's get the bone. We're going to use this as our transform. Make sure we check initial here and fill this in. Okay, so it looks like our ball left ball reference control, it's there, but it's very difficult to see. So I'm actually going to move this up using this shape transform so that we can see it a little bit better and it's clear. The pivot is in the exact right place, but let's just move up the shape only so that it's a little bit above the foot. Let's go back here, scale this down slightly. Okay, so that way we can pick this control. Now we have one more that we need to place, and that is this null, which references the original foot position. So let's go ahead and do that. So let's take this null and we're going to set its position. We're going to set its position to the foot control. So here we go. We're getting our foot and we're going to set our null position, initial value, compile. Now the null is difficult to see that it's in the right place, but we should be set. Now, in general, if we wanted to see that, something that I'll sometimes do is I'll just add a control to it, just a new control, and that will quickly pop a visual in so I can see that it is actually positioned where the foot is, and then I'll just delete it. Okay, so now that we have our hierarchy defined, let's compile and save this just so that we have it, just in case we get the crash. You'll notice that if we move this, we don't see anything because our null is not there, but if we rotate our toe, you'll see my ball rotates. And if we rotate the heel, you'll see that all of them rotate. Okay? Now all we need to do is connect this up. And so what we want to do is we want the IK to follow this left foot reverse position now instead of the foot control. Right now it's following this foot control. So if we move the foot control, you'll notice that my leg, the IK still works, but it does not pay attention to the reverse foot in all of the animation features that we want, because right now it's still following the foot and not our newly created end of hierarchy, which is this left foot reverse. So down here, this is pretty straightforward. What we're going to do is for our left foot, rather than following the foot control, let's change this to a null and let's change this to our left foot reverse. All right, so visually there's no change. Our foot still animates correctly, which is great. But now because we've defined this reverse hierarchy, I now have the controls where if I want to rotate the character up onto the ball of its foot, what I can do is I can pick this reverse ball control, and now when I rotate, you'll notice that my character's heel lifts off the ground, right? Same thing if I want to roll off the toe, which is awesome. And I can tweak the positions if I want to. Same thing from the heel. Now I'm going to actually, for ease, I'm going to take this heel and I'm going to move it up, much like we did with the ball, to make this a little bit more selectable and easier to grab. Okay, so now I can grab that a little bit easier. So let's compile and save that. Now, we are almost done. We're almost done. If you notice, our foot is working exactly the way we want it to. The only problem is we are not getting the counter animation of the ball, we're not getting that compression. We're not getting the taking of the weight, which is basically the floor stopping the toe from going through it. So how do we do that? All right, we need one more. You can use a control or you can use another null node. In this case, I'm actually going to use a null node. What we're going to do is we're going to create another node that we are going to put in that we can use as a reference for the original rotation of this ball. So let's go ahead and do that. And we are going to parent it to our toe in this case. So let's go new, null, and I'm actually going to call this one the left ball reverse. And what we need to do is we need to set its value up here. So let's set the left ball reverse to be the left ball of our foot. So let's get this. We will set its position rotation by default, which is great. If we, once again, if we want to see that that's, oh, we need to set initial here. If we want to see that that's actually in place, just to double check ourselves, if we right click and add a new control, it should show up right on the ball. Great. So now I know that this ball reverse is in the right place. All right. So now all we are going to do is we are going to add in one more. We're going to use something called a constraint. We haven't talked about constraints yet, but they are exactly like they sound like. If I would like an object to follow another object, I can create a constraint, a relationship between the two of them. And there are many different kinds of constraints. There are constraints in translation. So if I have one object and I want another object to follow it, I can constrain the second to the first and they would follow each other around without doing any parenting. So they can be separate in hierarchy, but they would follow in translation. So we can have translation constraints, we can have rotation constraints, we can have all kinds of different constraints. We'll go into more details about specific constraints and what they are in another video, but for now, just understand a rotation constraint is I am constraining the rotation of one object to another. And in this case, what I want to do is I want to constrain the rotation of the ball joint to our newly created reverse ball null so that it will effectively counter rotate. So what does that look like? So let's create down here in our graph, we're going to drag off of here and I'm going to create our first rotation constraint. And what we are going to constrain is the ball, the left ball, and we are going to add in the parent. And the item that we have here for our parent is not going to be a bone, it is going to be a null. And the null that we're going to use is going to be the left ball reverse. All right, when we do this, we should see no change because what we're doing is it's all going to be relative to where it was initially when it started. That's what this maintain offset does. So we should not see any change in our joints, no snapping, no popping, nothing. And now if we rotate our character's ball, you'll notice that my heel lifts, but look at what's happening. Our toe is counter animating. Why is that? Because this reverse ball is parented to the toe, it's not rotating. When we rotate this control, we're not rotating the ball reverse null. We're rotating the control. So this stays behind in the original rotation of the ball. And then what happens is the joint is now rotationally constrained to follow it. So it's not moving. So it looks like it's counter animating for us. But now in reality, all that's happening is the ball is actually constrained to the null. And if we take the null, if we were to take and rotate the null or convert the null to a control we could control, we could even put offsets on it, for example. But the overall point here is now that we've set up this constraint, the ball is actually counter animating for us and we can roll up onto our toe, and now we can also roll off of our toe if we want to get to that straight position. We can even kind of rotate backwards to get some nice drag, etc. But overall, effectively what we have set up now is a more intuitive way for a character animator to animate the foot. So it's that easy. That wraps up the creation of a reverse foot. It is called a reverse foot because it is actually an exact duplicate of the foot but in reverse order. And by doing so and leveraging the parent-child relationship, we are able to create the illusion that we have the weight and give the animator the control so that it feels much more intuitive to convey that illusion of weight on the ball. And we did that simply with basically creating 3 or 4 new nodes plus 1 rotational constraint. Most of this was just getting everything into position and parented correctly. So it's a very simple setup that allows animators to have the control that they would like. As always, if you like what we're doing here, help us out, spread the word, let people know what we're doing. Don't forget, check out the Discord and the Patreon, and also check out our live section. A huge amount of our tutorials and training are in the live section. We try to do those each week. My name's Kevin. Thanks for checking it out. See you all in the next one.